For the video retake, I want to just once again review that PRT stands for principal, rate, and time. And it's very important to remember that principal means the starting value of whatever kind you're looking for. The rate stands for the percentage, and you always want to think of the percentage as compared to 100%. So 5% increase would be 105%. 3% decrease would be 97% down. And then time stands for how many times that interest rate will tick each time. So if it's 5 years annual interest, the T would be 5. So let's get into an example. Mr. Schmidt just bought a brand new car that was priced at $25,000. And every year the car depreciates, which means decreases, by 3%. And how much will that car be worth after 10 years? So we need to make an equation in order to solve this problem. And we're obviously going to be looking at the y equals principal times rate raised to the time function. Now, our starting value for the car is $25,000, which tells us our principal is $25,000. Now, it depreciates or decreases by 3% every year. The important thing to remember is that we're always comparing it to 100%, and a decrease of 3%, I keep writing as a decimal, I think it's easier to write it like this, would be 97% left over, and we write that as a decimal in here. Now it says, how much will the car be worth after 10 years? I could put a 10 in for the time, and then I could simply solve this equation by typing this in. But what I also want to remember is that if I'm looking at creating a graph, I would leave this as a T, because I could then graph it a little bit easier and see what it would look like each year. For example, if I did year 1, that would be $25,000 times 97% to the first power. The car would be down to $24,250. Now, if I did this number times 97% again, that would give me the next year, or more likely, I would put it back into the equation like this. But either way, you'll get the same value of $23,522.50. Finally, I could do the third year, same process. Now, once again, I could do this number times 97% each time would give me the value. And I could do that 10 times. But like the last video, if we have the option, we want to use Desmos to help us graph these equations. Now, the car starts at $25,000, so I have to zoom way out to see that, and you'll see the problem pretty quickly. It doesn't look like an exponential function anymore because of how the zoom is going to work. Even if I zoom like this, it still doesn't look right. So I would go up here, and I would turn it into a table, and now I can see the value of my table each year. If I went down here and put in a 3, it would keep going. 4, 5, 6, 7, 8, 9, and 10 would be $18,435.60. So $18,435.60. So you'd say the car is worth $18,435.60 after 10 years. And that would be everything we need to do for this problem. Maybe we have to sketch a graph, but if we need an exact graph, we would use Desmos to help us out with that. Let's do one final problem. Your yearly salary is $28,400 after taxes. However, your boss promises you a raise of 2% every year. What would your salary be if you worked at this company for 40 years? One final time, we need to put our equation P times R raised to the T. Our principal in this situation is $28,400. Now, in this case, our rate is a 2% increase. So you always want to think about starting with 100%, increase, almost did it again, of 2% would be 102% of your principal every year. As a decimal, that'd be 1 2/100ths, written like that. Now, if we actually wanted to solve right away, we could put a 40 here. But if we were looking to graph our equation, which we are actually going to do, we would leave this as a t in the top, and we can then just graph, which we've actually done. So here's our equation. Now, once again, we notice here we got kind of a problem, right? Like we are in the negatives. Negatives don't really make sense. We can drag this up, but man, that's going to take a long time to do that. So we're probably going to do some zooming out, and all of a sudden, it's really hard to read this graph. So more than likely, we're going to make ourselves a table, and we could continue this process as many times as we want. However, it would just be fastest to click $40. And so if you worked at that company for 40 years, you would be making $62,708 a year after taxes, which means your salary would have over doubled in that time. So it shows you the power of exponential growth, because you're not adding $100, you're not adding $300, you're adding a percentage of your total value. So every time that salary increases, the next year the 2% growth will be even larger than before. So that video covered the basics of exponential growth and decay. As always, if you have any questions, please let me know.